We have to use a simple comma operator in order to differentiate between the values inside that square brackets. The operation through which we can access one element at a time, and that operation is called as traversing a list. If we have any of a word or a sentence, then that will be converted in a iterable form of a list. Nested list, as the name itself says, like whenever we have an operation which contains more than one number of lists. Hello everyone, I welcome you all to the third session of Unit 2, in which we will be discussing list. So yes, today we will learn each and everything regarding the list in Python programming. Alright, over here my name is Deepa Kutnikar. I am working as an assistant professor at the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. In today's session, we will be discussing these things. We'll be starting with understanding what is a list, then followed by how to create that list and what are the different operations that we can perform on the list. Followed by, we will also learn and understand what are the various built-in functions that can perform altogether with the list. Then we will be understanding like what is a stack, what is a queue, then followed by how to implement the stack as well as queue using this list. Followed by, we will be understanding regarding nested list. So these are the things that we discuss in our today's session, but is none other than agenda of today's session. So let's move forward and understand like what exactly a list is. As the name itself specifies, list in the sense we will be having some ordered information that we can call as a list. Now, with respect to Python, we can say that list is none other than ordered as well as mutable collection of elements that is completely enclosed in a square brackets. Yes, if anything is written inside the square brackets and it is in ordered form as well as mutable form, then we can exactly consider them as a list under Python programming. The main thing to note here is the square bracket. So we have to write our list inside the square brackets. Now let's understand like what is the advantage or feature of list, like why we want to go with list. Because list supports indexing, it supports slicing, then it allows storage of different data types information, as well as we can also store the duplicate values or we can represent the duplicate values. There is nothing like, yes, we have represented a number 10 and then again we are not supposed to represent that. Yes, it is possible. We can duplicate the values and any data type can be represented in a list inside that square bracket. So that is the main advantage that list provides for us in order to go with our operations. Then, as I told, list can store even the heterogeneous data type values. Then the indexing, as I told, yes, indexing can be done inside the list and it starts as usual from 0. Yes, this is that the indexing of list can start from 0 followed by 1, 2, etc. So now let's see a simple example for that list. Over here we have represented these numbers as a list format and it is in an ordered form, correct? Yes. The first one we can see that it is in a single data type. But here with respect to next, that is under items list, we can see here we have numbers, we have characters, we have words. So in this way, any data type can be represented inside a list. So these are very simple example, and over here we can see that the indexing values, it starts from 0 followed by 1, 2, 3, etc. So this is how we can represent a list. Great, right? Isn't it same as the list that we maintain in order to store our information, isn't it? Yes, absolutely it is. All right, let's move forward and understand how to create a list. So the creation we did understood, we need a square bracket. But now if we have multiple values, then how to differentiate with those? Yes, we have to use a simple comma operator in order to differentiate between the values inside that square brackets. Then as we did discuss, it can store any form of data type. Okay. So that's how we can create a list. So let's say an example over here. We are considering a variable as 1, 2, 3. So we have defined the values for A, and for B we have not yet defined. We have just defined a list. Now let's see what happens. Again, with respect to C, we have defined multiple data types, isn't it? We have considered a number followed by words, then again a fractional values or a floating point value. So everything can be considered under the list. Now let's move forward and understand, is these are the only ways to create a list? Are there any other ways? Yes, let's discover that here. So we can move forward and create a list by using various methods or built-in functions. For example, we can use list followed by open and square brackets, then range followed by open and close brackets. So we can use the small functions or a constructor in order to define our list. Let's see an example for this. So we have considered nums and we are describing list of range. Again, we are considering range followed by 1, 6. Okay. So we can observe that we are creating a list and using that range function in order to define that. Up next, similarly, we have one more example where we did consider squares and we have defined few consideration, that is x into x for x in the range of 1, 5. So in this way, we can use list constructor and we can also utilize that range function in order to describe or create a simple list. All right, when we did understood like what is a list, how to create them, now let's move forward and understand like what are the different operations that we can expect with respect to list. So operations on list means like anything that we want to do if we create a list. Like if I create a list, sometimes I would like to change that index value or access the elements through the index values. Yes, I have to do that. Or sometimes I can also go with updating the elements inside the list, or there will be requirement of inserting new elements or deleting the element which is present inside the list or traversing them. So in this type, we need multiple set of operations if we consider a list, right? So that's what we will be learning and understanding under operations of a list, starting with accessing the elements present inside the list using index values. So how this happens? Yes, absolutely. For each and every element, we will be representing it with a particular set of index value which starts from 0, isn't it? So let's consider an example here. We have defined A of 10, 20, 30. Now, if I want to print that A list, then let's see what is that index value I have defined in order to print. Yes, I have defined first element to be printed. As I know, the indexing starts as 0, 1 and 2, isn't it? Now, I want to print the first element. So, which is the first element? It is none other than 20. So, I am representing its value. The index value of 1 is 20. So, that's how we can access the elements using its index values. Okay. Next, if I want to access or print this A of 2. So, what is the A of 2 value? It will become 30. So, this is how we can access the elements. Next, if I want to update any of the element inside the list, then how is it possible? Yes, exactly, it's possible. That's by again utilizing that index number. So, I'll be considering its index number and I'll be defining the value that has to be updated in that place. So, that's how the value will be updated. So, now let's see an example here. Again, we have considered the same thing, that is A, which has been represented by a list of 10, 20, 30. Now, I want to update a value. Which is that value? A of 2 with 35. Let's index as 0, 1, 2. So, for 2, what is the value which is already present? It is none other than 30, right? Now, what we have to do? We have to update that element with a new value of 35. So, in my output, I'll be writing print of A. Finally, what happens? The A will get updated with a new value of index 2. So, you can observe we have 10, 20 further for 30, the value has been updated with 35. So this is how indexing works, and it is very, very helpful with respect to list to understand, to apply any of the operation with respect to list, isn't it? Yes, great. The next operation that we can consider under list is none other than inserting new elements. So now we have to completely add a new element. So for that we can utilize various keywords like append or insert of. Okay, so we can utilize append of or either insert of methods. All right, let's say an example here. We have 10, 20, 30 with a which is defined for A. Now what we are defining, we have to insert few values, correct? So we are writing the statement A dot insert of 1 comma 15. Let's see what happens with respect to output. We can observe here the index value of 1 is been added with the new element of 15. See, 0th index, yes, 10, it remains same, and 1th index is been updated with 15. So yes, so this is the updated value. Rest values will be retained as it is with new index values. Okay, so this is how we can access, then update as well as insert the elements inside that list. Also, we have further operations too. So let's see. The next operation is deleting elements. Now, in some cases, inside the list, there will be an element which is of no use. And for that element, if we keep and follow it up, the process becomes maximum. So, only if it is required, we can contain it or store it inside the list. Whenever it is not required, we have to go forward and delete that element, isn't it? So that's why what is the keyword that we can utilize to delete that element or a specific element inside that list is by using either a remove of or pop operation. Yes, both does the same operation. Let's say an example. Here we have considered a standard example. A is been assigned with 10, 20, 30. Then what we are defining A dot remove followed by which is the value it has to be removed. So here you can note we are not giving index value. We are directly providing the element, isn't it? Okay. Now print of A. So in output we can observe that we have 10. Okay. 20 is removed and we are retained with 30. So the updated output is 10, 30. Next, if I want to access the element one by one, is there any method or the operation? Yes, absolutely. The operation through which we can access one element at a time, and that operation is called as traversing a list. So, if we consider an example here, that is A of our standard example 10, 20, 30, and if I want to do this traversing, I want to write a loop. Okay, it works only along with a loop. Please note this. We can do this only by using a loop. Now we have to print x. So how the x will be printed at the output? So it will be printed in this format, like one element at a time. All right, these are the operations that we can expect or do with respect to list. Now let's move forward and understand like what exactly the built-in functions that are available to perform or work along with list. So the first built-in function that is very, very helpful and useful whenever we go with a list operation is a len of, which is used to return the number of elements present in that set of list. For example, if I have 10, 20, 30, 40, now let's say print length of A. Then as we can see, what are the number of elements that we have or the length of the list? 1, 2, 3, 4, correct? Yes. At the output, we will be provided with a length of list that is 4. Great. Next type of built-in function is max of, which is used to represent the maximum value inside that list. Let's see an example here. We have 10, 25, 5 and 40. So according to our knowledge, which is the maximum value? Yes, it is 40. Now, Let's see, do we get the same value at the output? Yes, for that we need to write this print statement where we have print max of A. So now followed by output, which gives us a maximum value present in the list. This is our second built-in function. Next type of built-in function is none other than min of. As we got maximum value, in the same way, sometimes we may need that minimum value that is present in that element. So for that, the built-in function that we have to use is none other than min of. So let's say an example for that. We have our A, which is defined with A 25, 5 and 40. And with respect to this, which is the minimum value? Yes, it is none other than 5. Now let's see, do we get the same value at the output? For that, we need to write the print element as print of min followed by the variable A. So it will give a minimum value that is present in the list, which is correct. We will be resulting with the output of 5. The next type of built-in function is sum of. It is used to represent the sum of elements that is present inside that list. Let's say an example for that, which has A defined with 10, 20, 30 followed by, if I want to get a sum of that, so let's write a print of sum of this variable A. Alright. Now, what is the sum? 10 plus 20, 30, 30 plus 30, 60. Yes, that's right. We will be resulting with the output of 60. Next type of built-in function is sorted. So this will result in a new list which is sorted with ascending order of the elements. For example, we have 30, 10, 20. Now, if I give a print of sorted followed by the variable A, which has a list value, correct? Now let's see at the output, we get the values that is being arranged in an ascending order, that is 10, 20 followed by 30. So this happens when we go with a sorted built-in function. The next type of built-in function is none other than any of. Here what happens is it is used to return true value if any one of the element present in that list is correct or proper, or we can say it is true. So let's say an example for this. We have 0, 0, 5. Now we will write a statement print of any of this list A. Okay. Then at the output, I'll get true. Why? Because yes, I do have at least of one element which is true. So my result will be also a true. Great. Up next, the next type of built-in function that is available is all of, which says like, is all the elements present in the list are true. If all the elements are present, then we get a true value. If any one of the element is missing, at that time, we get a false output. Okay. So let's say an example here, we have A, which has been defined with the list of 1, 2, 3. And we are writing a print statement which is using all of A. So at the output, yes, we get true. Why? Because we have all the values or all the elements defined inside. Great. Next type is list. Here we can consider if we have any of a word or a sentence, then that will be converted in a iterable form of a list. So let's see an example for this. We have A, which is defined by list of Python. So Python is a word which we have written all together and representing it as a list. But as we know, list, if I want to define, then it has to be written in a square bracket followed by separated by commas, correct? So now we have to bring this in that form. So we are writing print of A, and the output we can observe that our iterable object is been converted into a list form. Okay, so this is how the built-in functions can be utilized with respect to list. Now let's understand the implementation of stacks and queues inside the list or by using list. Is it possible? Yes, absolutely it is possible, and we can go forward to do that by using various built-in methods that we have discussed now. Okay. So let's understand like what exactly a stack is and how was it implemented. Alright, a stack in Python is a linear data structure that is represented by last in, first out principle. It is much like a pile of plates where the last plate is placed on top and that is the first one to be removed out from that queue. Okay, the elements are removed and inserted from the same end, that is only the topmost thing is what we will be using in order to insert or in order to remove the things or the objects. So now in order to remove and insert, are they both same? So what is it called as, or technically what is it called as? Let's see. So the first stack operation is push, which means that inserting an element into the stack. And we have one more operation, that is pop. When we use push to insert, then pop is used to remove. Thus, it is used to remove the topmost element in that stack. Right, now let's understand how the stacks can be implemented. What is the syntax for that? Yes, the stack implementation, the append is used to push an element, and in order to remove, we use this pop keyword, pop off. It is used to remove the topmost element from that stack. So for this, let's consider an example, and we have a keyword that we have defined initially, stack off. Now under this we have to define the list, like we can consider 10, 20, 30. Alright, now let's see how these elements are inserted or removed. So now what is our first operation? We have to append. In the sense, we will be starting with appending the values. Alright, now let's start with appending. So we have these three appends, that is stack append of 10, stack append of 20, followed by stack append of 30. Yes, now let's start appending or pushing the values. First, initially let's take 30. Okay, the 30 is pushed in. Next, in the next step, what happens? Along with 30, we will be pushing one more element, that is 30 as well as 20. Okay, now please note we are remaining with the last element, that is 10. So we have to append that too. 30, 20 followed by 10. Now, as we know that stack works on the principle of last in, first out. And what is that principle called? Last in, first out, isn't it? So now let's see what will be the result. So for that we have stack.pop. So it has to pop out or remove the elements. If we start with removing, so which is the first element that we are supposed to remove? Yes, which has inserted lastly, that is the first element which has to be removed. Now these are the push operation. Now let's go with the pop. So at the pop, what happens? The first element which comes out is a 10. Next, if we have one more pop, okay, then the next element that we can expect is 20. So this is the first and this is the second element which is popped out. So this is how push and pop operations will take forward or take place. If you have this question, then please explain with the example with each and every step so that you'll get good marks. Okay? Alright, now let's move forward and understand what is a queue. Now, under this queue, the principle what we follow is first in, first out. But with respect to the stack, the principle we followed was last in, first out. Correct? Here, the main thing to note is the elements are inserted in the rear and it is removed from the top or the front. Clear? So, we have two operations even here to follow with queue. The first operation is NQ and next is DQ. NQ in the sense, we will be inserting the elements into the queue, and DQ in the sense we can remove the elements from the queue. So these are the two important operations that we use as push and pop that we use for stack. So as we go forward with Q, we have to go and understand like what are the keywords that is utilized to insert as well as remove. Yes, exactly. Even we do use the same keywords like append off in order to add and pop off in order to remove or dequeue. Yes, we have a keyword that is Q equals off. Yes, this is a exact syntax where we will be defining a list, then followed by we will append various values like 10, 20, 30. So what is this process called as enqueuing? Up next, if I want to remove it, then the keyword that what we use is a pop-on. Finally, we have to print that Q. Okay, let's see what happens here. Now let's go with inserting. So the first value what we can insert is 30, followed by the next value what we can insert is 20. Then we have one more value that is 10. So this is how we will be appending or enqueuing. So this is a process of enqueuing. Now if I want to remove an element, then what is the process that it follows? Please remember the process. What it follows is first in, first out. Okay. Now for first in, first out, do you remember which is the first element we have inputted? Yes, it's none other than 30. Next, if I want to remove the next element, then which is the element which is inserted? It is 20. If I am satisfied, I'll stop here. Okay, I just wanted two elements to be retained back or dequeued. So at the output, we can observe that we will be resulting with 20, 30. So this is how enqueuing and dequeuing follows. But don't forget to write the principle which is followed for queue as well as stack. So now let's see a simple comparison of stack as well as queue. As we know, the first point comes here is stack follows LIFO, that is last in first out, and queue follows first in first out. So it is based on these principles. And under stack, we know that insertion as well as deletion is at the same end, that is at the front end. But it's not the case with respect to queue. If you want to add, you have to go with the rear end. And if you want to remove it, you have to go with the front end. Okay. Yes, please show the same thing. Add it from last. Okay. And remove it from first for this example. Am I clear? Yes. And the keywords that is utilized under stack are append and pop. And with respect to the queue, it is the same thing, append and pop of 0. Great. So these are the main difference between stack and queue. Up next, let's understand what are nested lists. Nested list, as the name itself says, like whenever we have an operation which contains more than one number of lists. So at that time, the multiple list can be resulted. So that multiple list is termed as nested list. And this nested list is commonly used in order to represent various matrix values, the statistical values, as well as tables, or we can also go with structured data. Let's see a simple syntax for this. Like we have a list name, which is element 1 followed by element 2, element 3, element 4. Isn't it? Now let's see an example of a nested list where we have a matrix with elements. Okay. So till now what we were seeing was a simple list where we have 2 to 3 values. Correct? Now we have multiple lists in this way, and that is supposed to be understood or termed as nested list. So by this example, we can note that matrix has 2 lists at a time. So that is called as nested list. Now with respect to nested list, what are its advantages as well as applications? So let's see that. The advantages is it represents multi-dimensional data and it is easy to implement, followed by it is flexible and provides the dynamic structure. The applications of nested list are, it is used to represent, or it is used under matrix operation, it is used for storing tabular data. It is also utilized in game boards or grids. Also, it is used for data processing tasks. So these are the applications of nested list. Great. So this was all about today's session, and in next session, that's under unit 2 itself, we have one more topic, that is none other than dictionaries. Yes, in our next session we will be discussing these things like what is a dictionary, how to create it, what is the keyword, what are the built-in functions, and so on. So these are the things that we discuss in our next session, that is session 4. All right, thank you.